To determine the boiling point of water, we can take a test tube, a Pyrex test tube, and add a small amount of water to that. Only about 2 to 3 centimeters or so of water in the test tube. Then, to prevent the water from superheating and shooting out at once, add a couple of small stones to the water. And these could be just some stones from gravel. They should be rough stones. Put them in the bottom. They serve as nucleation sites for the boiling and will prevent the water from superheating and shooting out. Then we can set the test tube at an angle and make sure the test tube is pointed away from students and any other thing that could be damaged by water shooting out. And then we take a thermometer and we can lower that into the liquid as we heat it. Now again, using an alcohol burner. The alcohol has a little bit of sodium chloride added to it to give a yellow flame. And the temperature rises fairly rapidly as the liquid is being heated. And we can now see vigorous bubbling, and the bubbles form then at the tips or the edges of the little pieces of gravel. We need to heat it for a little while in order for the thermometer to also respond and increase in temperature. We're now experiencing a change in state as the water itself is converted into water vapor. Water vapor itself is colorless. We cannot see it, but as soon as it comes out of the test tube, it cools down and forms droplets of water, which we then see as steam. Alcohol thermometers are fairly inexpensive, and they don't necessarily give the exact temperature. And so I'm finding that the boiling point here is about 98 degrees Celsius. That is due partly to perhaps inaccurate thermometer. It can also be due to a difference in atmospheric pressure, since the atmospheric pressure itself affects the boiling point of a liquid. So the temperature is at about 98.5 degrees Celsius. So that gives us the boiling point for water. It's a good idea to do a second liquid and determine its boiling point, just to show students that different liquids have different boiling points. I'm taking some methanol, or methyl hydrate, and I'll add a couple of little stones to it again, place it in my clamp, and add the heat and insert the thermometer. Methanol is a flammable liquid, so you want to make sure that you don't use an awful lot. That's why it's also good to do this as a demonstration. And it has a lower boiling point than the water. If it boils a little bit too rapidly, just slide the burner back a little ways so that not as much heat is added to the liquid. The boiling point in this case is about 65 degrees Celsius. So that's another physical property of the liquid. its boiling point. Again, notice how smoothly it boils due to the presence of the little stones that I put in there. If I don't include the stones, it tends to bump a little bit and occasionally can actually shoot the liquid out as it superheats. So the little stones serve as nucleation sites for the vapor to actually form. So what we have in this portion of the tube is methanol vapor. Again, a gas that is not visible. So we have another change in state here.